Number 10. If electrons are involved, if electrons involved in bonding spend most of the time closer to one atom rather than another, the bond is considered polar covalent. Okay? Now, let's unpack this question here. If electrons involved in a bond, so we're talking about two electrons in a bond. If they spend most of the time closer to one atom rather than the other, it's polar covalent. Now, how could we change this question so that the correct answer would be an ionic bond? Well, if the electrons involved in bonding, well, we actually wouldn't even see that term. But I want to point out the spend most of the time. With an ionic bond, there aren't shared electrons at all. There's not an electron that's going to spend most of the time near one, some of the time near other. That electron that was transferred is 100% a part of that atom now. It's not mostly that one, it's that atom's electron now. And so when we see this type of language, spend most of the time, okay, it's definitely not ionic. Definitely not ionic, because that electron has changed ownership. Okay, it's not a sharing issue. It's not most of the time sharing this way or that. It's a transfer of ownership. Now, the reason that we know that this isn't non-polar covalent is because the electrons involved in bonding are spending time closer to one atom rather than another. If we wanted to change this question so that the answer was non-polar covalent, the question would need to read something like, the electrons involved in bonding spend equal amounts of time around one atom and the other. Okay, they spend most of the time in between the two nuclei. Then the correct answer would be non-polar covalent. But because the question says spends most of the time closer, we know it's polar covalent.